Today we are diving into what's called Retrieval Augmented Generation, or RAG for short. Now when people talk about RAG, it's easy to think it's just one thing, a single model maybe, but it's not. It's actually an entire system, a whole pipeline of different parts all working together. So let's get into the blueprint.
So let's just start with the number one question, right? The core problem everybody's trying to figure out. How do you get a powerful AI, like a large language model, to actually know about your company's private internal stuff? You know, your wikis, those endless PDFs, all your policy docs, and how do you do it without having to do some crazy expensive retraining of the model?
Well, the short answer is it doesn't. It doesn't just magically learn it. Nope. You have to build a system that can feed it the right information at exactly the right time. And honestly, the best way to think about this system is to imagine it as a knowledge factory. So today, that's what we're going to do. We're going to take a tour of that factory floor. Every single one of these knowledge factories, these RAG systems, they're all built from pretty much the same blueprint. And this blueprint has two main wings, two major phases. First, there's the offline indexing phase. This is where all the prep work happens behind the scenes. And then there's the online querying phase, which is the part that kicks into high gear the very moment you ask a question.
Okay, so let's start our tour in that first wing. We'll call this section Building the Library. This is the offline, behind-the-scenes process where we take all of your raw information and we turn it into this highly organized, super searchable library that the AI can use later on.
Inside this library building wing of our factory, there are four main stations that every single piece of information has to pass through. It's loading, then chunking, then embedding, and finally storage. Let's take a quick look at each one.
It all kicks off here, at Document Loading. You can think of this as the factory's loading dock. It's where you bring in all your raw files, your PDFs, your Word docs, web pages, really, you name it. And special tools here parse them all, pulling out the clean, usable text and any important metadata, like, say, the name of the source file.
Next up, the files move to chunking. Look, a 100-page document is just way too big for an AI to digest all at once. So chunking is like taking that giant book and breaking it down into smaller, neatly indexed paragraphs or sections. These smaller chunks, usually about 500 to 1,000 tokens, make it so much easier to find the exact little piece of information we need later on.
And now for the really cool part. It's basically a magic trick. Embedding generation. At this station, we take every single one of those text chunks and we use a special model to convert its meaning, the semantic meaning, into a long list of numbers. We call that a vector. This is how the machine understands relationships. Chunks of text that mean similar things will have mathematically similar vectors. It's literally translating language into math.
And the final stop in this wing is vector storage. All of those numerical vectors, each one representing a little piece of your knowledge, they all get stored and indexed in a special kind of database, a vector database. Now, this isn't just some dusty filing cabinet, it's a high-speed search engine for meaning, and it's ready for action. And with that, phase one is done. The library is built.
All right, let's walk over to the other side of the factory floor now, the live query assembly line. This is the online part of the system that just springs to life the instant a user, someone like you, types a question into the search box. And this assembly line, it moves fast. It starts by figuring out your query, then it instantly retrieves the most relevant info from the library we just built. From there, it might re-rank those results for quality, assemble the best pieces into context for the AI, generate the actual answer, and then, finally, it polishes it up with a little post-processing. Now this is fascinating. Take a look at where the time is actually spent during a query. All those retrieval steps, like the vector search, they're incredibly fast. The real bottleneck, the thing that takes up a massive 80% of the time, is the large language model just thinking and generating the answer. This is a super critical insight. If you want to speed up your RAG system, optimizing the generator is where you'll get your biggest wins, by far.
So what does this all add up to for the person asking the question? Well, the total experience time is typically somewhere between about 0.6 and 3.4 seconds. It's a lightning-fast factory, really, with thousands of operations happening in the time it takes you to blink.
So, we've toured the factory floor, we've seen how it all works. Now, let's step into the architect's office. Because, you see, building a good RAG system isn't just about plugging in components. It's about making really important design choices and trade-offs that will completely define how well your system actually performs.
And the first big decision you have to make is all about chunk size. Do you break your documents into small, precise little paragraphs or into larger, more context-rich pages? Smaller chunks are fantastic for pinpointing very specific facts, but larger chunks, they're way better for answering broad, summary-style questions. It's this fundamental trade-off between precision and context.
Next is a decision called top K. Now, K is just a fancy way of saying how many chunks should we retrieve from our library to answer the question. If you retrieve too few, that's a low K, you might not find the answer at all. But if you retrieve too many, a high K, you risk drowning the AI in a bunch of irrelevant noise, which can actually hurt the accuracy and drive up costs. It's a really delicate balancing act.
This really highlights the value of an optional but very powerful step called re-ranking. See, after the initial fast retrieval, you can use a second, smarter model to resort the results and find the absolute best chunks. And the payoff, it can be a significant 10 to 30% boost in relevance. The only trade-off is that it adds just a little bit of time to the query.
So, as you can see, you don't have to build the world's most complicated, high-performance factory on day one. RAG systems can evolve over time. Let's take a look at how a simple starter RAG system differs from a more advanced, souped-up one.
A simple system, your starting point, might just use fixed-size chunks and a basic semantic search. But an advanced system, it gets smarter. It uses adaptive chunking that understands the document. Its retrieval combines semantic search with old-school keyword search in a hybrid model, and it adds that powerful re-ranker we just talked about. Instead of just sending raw chunks to the AI, it might compress or filter them first. And finally, the generation step might become multi-step, where the AI actually double-checks its own answer. You start simple, and then you add complexity where it really matters most.
So there you have it. That is the complete blueprint for a RAG knowledge factory, from the loading dock all the way to the final product. Understanding this architecture is really the key to building powerful, accurate AI systems. But, it also brings up a really crucial question. Now that you know how to build the factory, when is it actually the right tool for the job, and when should you consider something else entirely, like fine-tuning? We'll tackle that one next time.